Hello, today we're going to be talking about lesson 4.2, which is on angles of triangles. Theorem 4.1 is the triangle angle sum theorem. It says that when you add up all the angles in a triangle, for example in this one, angle A, angle B, and angle C, they should all add up to 180 degrees. So if we were going to prove the triangle angle sum theorem, it requires us to use some sort of auxiliary line. And our vocabulary word is auxiliary line. It's an extra line or segment drawn in a figure to help analyze geometric relationships. So for example, last chapter, we talked about an auxiliary line to find the perpendicular, to find the distance. It was a dotted line. We could do the exact same if we were to find and to prove angle or theorem 4.1. So here is the proof. It's actually included in your notes. And you'll see that what we have to do is first we have triangle ABC. Okay, that's given. Now, if we were to draw AD through A would be parallel to BC. So here's our dotted line right here that we've drawn. That's our auxiliary line. Okay? And that's the parallel postulate uses that, saying that we can do that, making it a parallel line. Now, angle 4 and angle BAD, angle 4 and angle BAD, which is right here, are supplementary. Remember, supplementary angles add up to 180 degrees. That means that the measure of angle 4 and the measure of angle BAD is going to equal 180 degrees. Now, BAD is also, or really equal to, angle 2 plus angle 5. So we can substitute angle 2 and 5 in for BAD. So that means that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is going to equal 180 degrees. Now, you'll see that angle 4 and angle 1 are congruent. Angle 4 and angle 1 are congruent. Remember, their special name is alternating interior angles. Also, you'll see that angle 5 is congruent to angle 3. Again, alternating interior angles. So what we can do is we can actually substitute angle 1 in for angle 4, angle 3 in for angle 5, and we see that the measure of angle 1, 2, and 3 all add up to 180 degrees, which is what we wanted to prove. And again, that uses substitution. So it's proven that our theorem is correct, and it is true. So let's look at an example. It says the diagram shows the path of a ball in a passing drill created by 4 friends. Find the measure of each numbered angle. Alright, so first, angle A is 20 degrees. And angle C is 78. So to figure out angle 3, we know that it's going to be 20 degrees plus 78 degrees plus the measure of angle 3 is going to add up to 180 degrees. So 20 and 78 together is 98 degrees plus the measure of angle 3 is going to equal 180 degrees. Now I can solve it just like an algebra problem. Subtract 98 degrees from both sides. And the measure of angle 3 is going to be 82 degrees. There's my first answer. Okay? Now, in the second triangle, they tell us what E is, but they don't tell us what 2 or 1 are. Well, first we can figure out angle 2. The measure of angle 2 is going to have to be known. And we can actually see that those two are right across from each other. They have a special name. Remember, that special name is called vertical angles. And vertical angles are equal. So the measure of angle 2 is actually 78 degrees. So I know that this one is 78 degrees. So now that I know two of the measures, I can use that information to find the third. So I set up my problem very similarly. I say 61 degrees plus the 78 degrees that we already knew, plus the measure of angle 1, which is what we're looking for, have to add up to 180 degrees. I combine my angles. 61 and 78 is going to be 139 degrees, plus the measure of angle 1 is going to be 180 degrees. Again, just like an algebra problem, I subtract 139 degrees from both sides, and I find the measure of angle 1 to be 41 degrees. Those are all three of their measures. Here's some guided practice problems that we can try later. Now, exterior angle theorem. Okay? So, we know all of the interior is the inside of my triangle. And so there's always these angles left over on the outside known as exterior angles. So our exterior angle 4 right here, it says 4 is an exterior angle of ABC. Its two remote interior angles are angle 1 and angle 3. Notice they're the two that are not touching it. So angle 2 is touching angle 4, so 1 and 3 are my remote interior angles. So let's look at this theorem right here, theorem 4.2. It says, the exterior angle theorem says this: the measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles. So if I'm looking right here, angle A and angle B are going to add up to the measure of angle 1. Just like in our example right here, angle 4 is equal to angle 1 plus angle 3. So a flow proof is a different type of proof. It kind of draws, it's like a flow chart. You see these in business and models and things like that. So it says, given that you have triangle ABC, we want to prove that the measure of angle A and the measure of angle B is equal to the measure of angle 1. So essentially this is what we're going to do. We're going to say we have triangle ABC. Okay? We know that angle A, angle B, and angle 2 in this example all have to add up to 180 degrees. That's already known. Okay? We also know that angle 2 and angle 1 form a linear pair, meaning they're supplementary, meaning they add up to 180. So notice they both add up to 180. If they both add up to the same thing, they're equal to each other. So I can set them equal to each other. So A, B, angle 2 is equal to angle 2 and angle 1. Well, if you have the same thing, angle 2 in both of them, what I can do is I can essentially just subtract the measure of angle 2 from both sides. Then it's gone, and you get the measure of angle A and angle B add up to the measure of angle 1. Makes sense. They all have to add up to 180 degrees. Those two straight linear pair add up to 180 degrees. So if you take away the same angle that's in both of them, they're going to be equal to each other. Here's another example. Okay? Find the measure of angle JKL, that would be right here, in the triangle pose shown. So triangle pose is a yoga move. Looks just like that, makes a triangle with your feet. Okay, so I know that the measure of angle JKL, 2x minus 15, has to be equal to its two remote interior angles. So we see right here that would be x, and that would be 50. So the two of them are equal to each other. Now it just becomes a straight algebra problem, moron problem. Obviously there's more x's right here, so I subtract all the x's to that spot. I get x minus 15 is equal to 50. Add 15 to both sides, and you get x is equal to 65. Now, did it say find the measure of angle, or did it say to find the value of x, or did it say to find the measure of angle JKL? Well, it actually says to find the measure of JKL. So I'm not done yet. I have to take the 65 and plug it in for x right there. So I do that. 2 times 65 minus 15. 2 times 65 would be 130 minus 15, which would equal 115 degrees. You could check that by saying, well, x is 65, that is 50, 65 and 50 also add up to 115. So we know we got the correct answer. Here's an example of a guided practice problem that you could try on your own if you'd like some more practice. Now, a corollary, another vocabulary word. Corollary is a theorem with a proof that follows as a direct result of another one. So first you find one theorem, corollary goes right after it. So here are corollaries. Corollary 4.1. The acute angles of a right triangle are complementary, meaning this angle, angle A, and angle B also have to add up to 90 degrees. Okay? So the measure of angle A plus the measure of angle B add up to 90 because we know that our right angle is also 90. Altogether is 180. Another one, corollary 4.2 says, there can be at most one right or obtuse angle in a triangle. And we talked about that earlier. Okay? You can't have more than one obtuse angle. Otherwise, you're going to have two angles that are bigger than 90, and you're going to have more than 180 degrees. Okay? So there can only be one right or one obtuse angle in a triangle. Example 3 tells us to find the measure of each numbered angle. So let's go in order. First, measure of angle 1. Well, we know the measure of angle 1 plus this 90 degree angle plus this 52 degree angle have to all add up to 180 degrees. So, measure of angle 1, 90 and 52 is 142. It's going to equal 180. We subtract 142 degrees from both sides. And we get the measure of angle 1 is equal to 38 degrees. Alright? So this one right here is 38 degrees. I know that. Okay? Now, number 2. Okay? Angle number 2 right here. Same sort of deal. Angle 2, 38 degrees and 90 degrees. So we say the measure of angle 2 plus 38 degrees plus 90 degrees has to add up to 180. Okay? Measure of angle 2 plus 128 degrees equals 180. Subtract 128 degrees from both sides. And we find the measure of angle 2 to be 52 degrees. Okay? Now, we'll go to measure of angle 3. Okay, measure of angle 3 right here. Well, how can I figure that out? Well, we see that we have a 90 degree angle right there. So both of them, angle 2 and angle 3, add up to 90. We also see that this is 52 degrees, and so this angle right here, okay, has to be 90 minus 52 degrees, which we've done a couple times, is 38. So the measure of angle 3 is 38 degrees. And finally, the measure of angle 4. Same sort of deal. We see right here, okay, we have a square, so this is going to have to be a 90 degree angle. So the measure of angle 4 plus measure of angle 1, which we found to be 38 degrees, has to equal 90. So the measure of angle 4, which we've done a couple times again, is going to be 52 degrees. So we have all of them. This is 52 degrees, this is 38 degrees, that's 52, and they all add up to 90 in the end.